Welcome to Serious Data Solutions. I'm Malcolm Chisholm. Today, we'll be looking at data universes, the outer limits. Just as we live in a universe that's bounded by space and time, so data sets and databases have their own data universes. These are bounded by semantics and operational processes. Today, we'll be looking at semantics, which produce the ultimate boundary for these data universes. But first, what is a data universe? Is it a valid concept? So questions like this we can go to the philosophers with, and a good place to look for philosophical concepts, or at least classical philosophical concepts, is Baldwin's Dictionary of Philosophy and Psychology, edited by James Mark Baldwin, a professor of philosophy at Johns Hopkins University around the beginning of the 20th century. And there we find the definition of universe of discourse provided by none other than Charles S. Peirce, a very brilliant man. And a universe of discourse is the set of individual things that are referred to in a logical context. Well, a database or a data set is a logical context, and it is trying to provide information about individual things. So I think we do have good reason for being able to speak about data universes. Now, the philosophers also provide two more concepts that are useful to us: extension and intension. If we can go back into the dictionary, we will find these definitions. And an intension is really the set of essential attributes that defines a corresponding set of concrete objects. The set of concrete objects is referred to as the extension. The word intention isn't great because it sounds very much like intention, meaning how we plan to act in the future. But this is the kind of accepted word today, so we'll use it. In Baldwin's day, comprehension was a synonym that was very frequently used, but again, we're going to stick with intention. Now, there's an inverse relationship between extension and intention, and we can see this with the example of animals. The set of essential attributes that defines an animal is rather small, but if we go from animal to vertebrate to mammal to human, each time we're adding more and more essential attributes, and each time we're narrowing down the corresponding extension, the corresponding set of concrete objects. So the lower the intention, that is the fewer essential attributes we have, the greater the extension, the number of concrete instances, and vice versa. So we can see this in databases with the classical design pattern known as the party model. The party model is where we have all types of people and legal entities in whatever role put into a single database table. So everything is in one table. A very low intention, but a very high extension. The opposite database pattern would be to take each one of these types of things and each role and put it in its own database table. Then the set of attributes, the intention, would be high, but the corresponding extension would be low. Now, there's pros and cons to the party model, and we can get into those in another video, but it's a good example of how we can think and see intention being applied and extension therefore qualified in database designs. From intentions, we can pass to definitions, and here's where we start to see the idea of the semantic scope running out for us in terms of being able to define data universes. If we look at the definition of a mammal, we can see that it applies to clearly all living mammals, but it also applies to all mammals that lived in the past and all mammals that will live in the future. And that's a little strange for thinking about what we've got in a database or a data set. So what we will do in the next video is consider how operational processes actually contribute to the full boundary, the full scope of our data universes. Well, I hope this has been useful to you. If this video has been useful, please like, subscribe, and share. Drop a comment below. I'll be putting up a link to the slides used here. And until next time, goodbye from me.